to see the topic discussion. So it is very important topic in which this scheduling. So already in the first unit we have studied the responsibilities of operating system. So some of them are memory management, CPU scheduling, deadlock handling. So these are all some responsibilities of operating system. So one of the major responsibility of the operating system is using the hardware efficiently. So if you think disk drive as a hardware, the main responsibility of operating system is how can we use the disk efficiently. So disk efficiency depends upon two factors, fast access time and high bandwidth. Access time again divided into two major components. One is seek time, the other one is rotational latency. So in order to efficiently use the hardware like this, we need to consider two factors, access time and bandwidth. So for that, we have developed several algorithms to service IO request. Some of the algorithms are first come first serve scheduling, shortest seek time first scheduling, scan scheduling, C-scan scheduling, look scheduling, and C-look scheduling. So these are some algorithms which are used in disk scheduling. So one by one we are going to see. The first one is first come first serve scheduling. So in order to explain the concept, as we consider our request queue, so request queue consists of 200 cylinders totally. Our disk consists of 200 cylinders totally. The request queue consists of the request for the cylinder 98, 183, 37, 122, 14, 124, 65, and 67. So totally 8 requests are there in a queue. Our current head pointer is at the cylinder 53. We are assuming that our current cylinder is at our current head at the cylinder 53. We assume that our head starts at the cylinder 53. So first scheduling is first come first serve scheduling. So the name itself implies first come first serve. So example is queue. So who is standing in front of the queue? He is serviced first. Example, theater queue or restaurant queue. So who is ration shop queue? So the person who is standing in front of the queue is serviced first. So the same principle here also applied. It is the very simple and fast algorithm. Here the IO requests are serviced based on their arrival. Okay. That is, in the queue, all the requests are satisfied based on their arrival. So our example queue consists of the request 98, 183, 37, 122 and so on. So the first request is 98. So it is serviced first. The second request is 183. So it is serviced second. 37, third request. Like that, we are servicing the request in order. So it is explained in this diagram. Our current position starts at 53. From 53, we are moving to the first request in the queue. It is 98. From 98, I am moving to the request 183 since it is the second request in the queue. And from 183, I am moving to the request 37. It is the third request in the queue. Like that, all the requests are satisfied in order. So this is simple and fastest disk function. For each algorithm, you have to calculate the total head movements also. So for this problem, the total head movement is 640 centimeters. How it is calculated means 53 minus 98 plus 98 minus 183 plus 183 minus 37, like that. But don't take 53 minus 98 as negative value. Just take the difference. You consider that value as positive. Even you get the negative value, you have to consider it as a positive value. Just take the difference. And the total head movements for this algorithm is 640 centimeters. The next algorithm is shortest seek time first scheduling. Shortest seek time first. So in the queue, you have to select the request with the minimum seek time from the current head position. From the current head position, you have to decide which request is having a minimum seek time. That request is serviced first. That's why it's called as shortest seek time for scheduling. So it is a form of shortest job first scheduling, which already we have discussed in CPU scheduling. The disadvantage of this algorithm is it may cause starvation of some requests. So example, again, the same queue is considered and the current head position is at 53. So the current head position, from the current head position, you have to consider the left side request and the right side request. Which one is having a minimum seek time? That should be taken. 53 minus 37 and the other one is 53 minus 65. So 53 minus 65, don't take it as negative value. Once again, I'm reminding it is just a difference. Okay, so 65, 53 minus 65 is minimum. So I'm going to the right side direction and I'm servicing the request 65. From 65, again, consider the left side request and the right side request. The left side request is 37 and the right side request is 67. 65 minus 37, 65 minus 67. Which one is minimum? Of course, 65 minus 67, it gives you a negative value, that is minus 2. Don't take it as a negative value. It is a difference, that is just 2. Since the right side service is giving you a minimum value, we are servicing the request 67. Again, from 67, I'm considering the left side request and the right side request. 67 minus 37 and 67 minus 98. So the minimum value is 67 minus 37. So I'm moving into the left side direction. So like that, I'm continuing until all the requests are satisfied in the queue. So the total head movements for this algorithm is 236 centimeters. The third scheduling is stand scheduling. The other name of this algorithm is elevator algorithm. So we all know the principle of elevator, which is used in construction places. So elevator, how elevator works, it moves from ground floor to the top floor. While moving, it gives you the materials at each and every floor. And once it reaches the top floor, the direction of the elevator gets reversed. It moves from top floor to ground floor. Again, in the reverse trip also, it can give you the materials, the needed materials in each and every floor. So the same concept here also used. The disk head starts at one end of the disk and we move to the other end. While moving, we are servicing the request. Once I reach the other end, I have to reverse my direction. During my reverse trip also, I'm servicing the request. So this is called scan scheduling. The head continuously scans back and forth across the disk. So see the diagram. My current head position is at 53. Either you can move into the left side direction or you can move into the right side direction. So I'm choosing left side direction. 53, from 53, I'm reaching 37. From 37, I'm reaching 14. And after 14, I don't have any request in the left side direction. But you should reach the end, that is 0. When I reach the end, I can reverse my direction. That is, I can move into the right side. While moving into the right side also, I can service the request. That is 65, 67, 98, 122, 124, 183. So again, calculate the total head movement for this algorithm. So that's about scan scheduling. The fourth type of scheduling is C-scan scheduling. So it is a variation of scan scheduling. The difference between scan and uniform is, the scan and C-scan scheduling is gives you uniform wait time than the scan. That is one of the great advantage of C-scan scheduling. What is the difference means? It is very much similar to the scan scheduling. We start from one end and we move to the other end. While moving, you can service the request. Once I reaches the other end, I have to reverse my direction. Here the difference. During my reverse trip, you should not service any request. That is very important. During your return trip, you should not service any request. Okay. So that is like this. My current head position is at 53. Since it is a C-scan scheduling, it is a variation of scan scheduling. Either you can move into the left side direction or you can move into the right side direction. So here I choose the right direction. So 53, I'm moving to 65, 67, 98, 122, 124, 183. Anyway, I don't have any right side request after 183, but I must reach the end. It is 199. Once I reaches the end, I can reverse my direction. See the difference? During my reverse trip, you should not service any request. That is very important. During your reverse trip, you should not service any request. From the other end, I can move into the right side direction. So I am servicing the pending request 14 and 37. So this is called C-scan scheduling. During the reverse trip, you should not service request. Other than that, it is very similar to scan scheduling. The last scheduling is look scheduling. It is also the variation of scan and C-scan. The difference is you should not move the arm to the end of the disk. You should move the arm only up to the final request in each direction. So it's called look scheduling. Once you reaches the final request in one direction, you should not need to touch the other end. You can reverse the direction and you can start servicing. This is called look scheduling. So another one variation is C-look. It is a version of C-scan. So that is during the reverse trip, you should not service the request. See, I'm starting from 53 and I can service the request 65, 67, 98, etc. etc. 183 is my final request in the right side direction. What we are doing in scan scheduling means from 183, I have to touch 199. But here you don't need to touch 199. Doing at the final request, you can reverse the direction. So once the direction is reversed, see the diagram here, we won't service any request. So is it look or see look? It is see look, because during the reverse direction, during my reverse trip, I won't service the request. Here also I don't need to touch 0. I just ended with the final request in the left hand direction, that is 14. I reverse my direction. During my second trip, I can service the pending request. So this is called see look scheduling and look scheduling. So that's about this scheduling algorithm. Once again, I am briefly explaining you. One of the main responsibility of operating system is using the hardware efficiently. So discuss one hardware. So the efficiency of disk drive depends upon two factors, access time and bandwidth. When you consider access time, again you have two major components, seek time and rotational latency. So we have developed several algorithms. Some of them are FCFS, SSTF, scan, C-scan, look, C-look. And we explain all the algorithms with this example. Thank you all.